In this lesson, we're going to be trying to answer the following questions. What are programming paradigms? What different paradigms are there? And why do we need these different paradigms? And then we need to understand the characteristics of each. Here's our link to the specification. In this unit, you're going to have to explain the difference between high and low level languages. You're going to need to be able to give examples, talk about their uses and their features, and thinking about different programming paradigms, again, examples of them, their uses and their features. Now we can recall that there is hardware, these are the parts of the computer, and hardware can only run through machine language, and we know this as binary, zeros and ones. These are what we call low-level languages, machine language and assembly language. They're not written in human English. Assembly language uses mnemonics, such as ADD for add. Remember, we have an opcode and an operand for assembly language. We have high-level languages. These are designed at the users, using higher level English, which a user could understand. For these to be interpreted by the computer and the computer hardware, they need to be translated or compiled from a higher level language to machine language, which can then be processed by the hardware. As we've just mentioned, low-level languages can be classed as machine languages and assembly language. So machine language like binary. These are machine-oriented languages. They actually don't have any built-in functions such as print, as you'd have in a high-level language. However, they can access directly the registers. So remember when we looked at the processors of the CPU, and we've got the MAR, the MDR, the PC, the ACC, etc. Well, these languages can access those directly. We use mnemonics to create processors within these languages. Remember, mnemonics are like add, ADD, in assembly language. Remember, there can also be different versions of assembly language depending on which processor you are using. The other type of language is a high-level language, and we've used several of these, including Python, Java, and you can also include things like JavaScript in these languages. They're problem-oriented rather than machine. This means they're really built for humans, using a high-level language that me and you would understand. Remember, these languages need to be compiled or translated in some form so that they can be understood by our computer. The different paradigms we're going to be looking at are procedural, object-oriented, declarative, functional, and assembly language. Let's start with the easy one, assembly language. We've used assembly languages before, and we know they're made of mnemonics. These are memorable sequences of letters, as we've said already, like add. They're used instead of machine code, and remember that these can be interpreted in the decode section of the FDE cycle. These do differ though depending on which processor you have decided to use. We learn Little Man computing, but if you look at the Intel assembly language, it will be different. This means we don't have a level of portability with assembly languages. We can't just transfer the language from one computer to another because we'd first need to figure out which processor it is using for. And this might mean certain programs which are written in assembly language cannot be used with other processors. The second paradigm I want us to think about is declarative. Now, we've heard this word and we think about this word, declarative, it comes from declare. We use programming language such as SQL, and a declarative language will actually use a series of statements, and there's one on the screen here. Now, this is interrogating a database. If you look at this instruction, we're giving it instructions such as select. This is saying go to a database, find some information, and present it back to us. And in this case, it's using the wildcard asterisk to say select all from a table called houses where the house equals Truro. You're not actually writing the logic of where to go to find it, how to find it, but you are, however, telling it where to go, and it will return any data values which have those criteria which are met. So we can think of it a little bit like it being different to the languages we're used to, because you're not writing how to do it, you're not putting the logic behind it, you're telling it what information you want. The computer takes this, analyses your statements, looks for the table, in this case called houses, and returns the data that you want. This is declarative, and you will find a lot of functional programs are declarative. We've done a lot of functional programming recently using functions and procedures. Well, functions, remember, return a value, and that's the difference between a function and a procedure. When you run a function, it's like having a small program within a program. We can call this function at any point, and it would return a value for us. We can also send it data so that we can personalize the outputs. Imperative programs use statements that change the state of a program using our three programming constructs: sequence, selection, and iteration. They use commands for a computer to perform certain tasks. We can think of procedures in a similar way to functions, and we've learnt about procedures and functions before. Procedural programming is blocks of programs. Often they don't return data to original programs and are run in a sequence. These blocks, though, can be called again and again. Object-oriented programming is a different way of programming and totally different to procedural programming. A lot of programming languages such as Java are naturally object-oriented, rather than Python, which does allow object orientation. However, it's not inherently built in to support object-oriented programming. We make different objects of the same code. So think of a class of students. In a class, every student might have a variable called name. They might have a variable called form, and they might have all sorts of other variables, including attendance, assessment, etc. And we can create different instances of this code. So you might have a different instance for each student. So each student would have in memory the object code for that program. So a different instance of it held in memory. It's actually becoming more common to do this, and particularly in games development we see object-oriented programming. We'll look more at object-oriented programming further through the course, when we'll look at things such as inheritance and encapsulation. We can actually solve most problems using any of our programming paradigms. This means most languages are said to be Turing complete. So that basically means that we could choose which paradigm is best for us and best for different situations. In your programming projects, you're going to have to think carefully about the structure of your code and what paradigm you're going to use. If you're doing a game, you might be best doing some object-oriented programming. This will suit the game better and will mean you can have different instances for, say, different characters. Try the exam questions now, look at the answers and then mark your answers. Think about what makes a good answer and look at the answers and improve your work.